We are going to uncover the fundamentals of API fuzz testing using tools like boofuzz. This will equip you to design effective fuzz tests and avoid common pitfalls. Let's begin with the core objective of fuzzing. The idea is to systematically send a range of unexpected, malformed, or edge case inputs to your API endpoints to uncover bugs, crashes, or security vulnerabilities. Think of it as stress testing your API's input validation and error handling. First, you must define your test target clearly. This includes specifying the target hostname and port, and creating a session with your fuzzing tool. For example, target host equals appyourdomain.com, target port equals 443. Then, you instantiate a session object with those details to start your fuzzing workflow. Next, to ensure meaningful results, always set static, valid authentication headers like valid API keys or tokens. This is crucial because many APIs reject requests without proper authorization, and if you only send garbage tokens, you won't reach deeper application logic. This static test case is your guaranteed successful baseline. After that, you want to list and prepare your fuzzing input values. This includes HTTP verbs, get, POST, put, headers with both valid and malicious values, empty strings, very long strings, script injections, and payload fields in the request body. Planning these carefully can make your fuzz testing more targeted and effective. Then comes the creation of two main types of test cases. The static success test case, a well-formed, authenticated request that passes server validation, letting you verify your testing setup. The fuzzing test case uses groups and blocks to systematically mutate selected inputs like HTTP method, headers, and body fields to explore how your API responds to unusual inputs. While building these, you should keep the fuzz case sizes manageable. Don't explode permutations beyond millions unless you have enough capacity. A good practice is to limit each fuzz group to a small set of high-value payloads. Now, some best practices. Start with small, concise fuzz groups and expand gradually. Always keep a known good static test case in the mix. Leverage the fuzzing tool's web interface or logging to monitor progress and crashes. Run fuzzing in stages to isolate issues by input types, methods, headers, body separately. Watch out for common mistakes like missing auth headers, overloading with too many payloads, or not validating if your inputs even reach the application layer. Remember, fuzzing is powerful, but can be expensive and sometimes destructive. Always run in controlled environments and monitor system performance closely. How groups and blocks help fuzzing? Let me break down what I mean by the fuzzing test case uses groups and blocks to systematically mutate selected inputs like HTTP method, headers, and body fields to explore how your API responds to unusual inputs. First, what are groups and blocks in boofuzz? Groups are lists of possible values for a field like a set of every HTTP method, or a list of potential user agent strings you want to throw at your server. For example, you might define Python sgroup, method, get, POST, put, delete, trace, sgroup, user agent, Mozilla, A1024. Blocks are logical sections in the request, such as the request line, headers, or body that can combine multiple fuzzable elements together. You might put all your headers in a block called headers, or all your JSON fields in a block called body. How does fuzzing use these? Once you set up multiple groups, a method group, a header group, a body content group, boofuzz will automatically generate test cases using every possible combination of those values, so you get broad coverage without manual effort. For example, if you have 5 HTTP methods, 3 header values, and 4 possible body field values, you'll get up to 60 combinations tested automatically. Using blocks, you can organize and manage the structure of each request, and decide which fields or sections to fuzz together or independently. This is important for APIs where the meaning of the request depends on a combination of fields, or where you want to test complex logic such as stateful authentication or protocol flows. What does systematic mutation look like? Systematic mutation means you are not guessing or randomly changing bits, but have defined rules for what will be tested. If you want to see how your server handles with HTTP verbs, broken tokens, big body payloads, you just add those to the relevant group or block. You can also do nested blocks for more advanced cases, meaning that you might fuzz certain sections only when another field has a particular value. Best practice examples: fuzz each input separately, verbs, headers, params, body to isolate where things break. Always group your critical protocol elements, like auth tokens, so your first test covers security edge cases as well as functional ones. Use blocks for logical layering. Put your headers in one block, your body in another. This keeps your scripts readable and manageable. Common mistakes: not setting up groups. Failing to define a range of diverse values means you won't uncover edge case bugs. Leaving blocks too broad. This can lead to meaningless requests that never hit valid code. Wasting test time. Over-nesting without clear rules. Too many nested blocks can make scripts hard to understand and maintain, so only use them when you need conditional logic.